Hello student, welcome to the new lecture of chemistry and we are doing the structure of atom. Till now we have discussed about these topic in this chapter and our today's topic is Bohr model. So after the failure of Thomson model and Rutherford model, Bohr gave a model. So let's see what was the postulate of Bohr model. Now guys, to understand about the Bohr's model, first we have to know about quantization. Now what quantization is? Let's take an example. Now this is a ball which is going down to this slope and its energy is decreasing continuously. So in this case, the continuous change in the energy is taking place. But if we take another example, this one, the energy is decreasing in steps. For example, if this ball has some potential energy, it is decreasing x joule. If it comes down, then it will come down another x joule, then another x joule. So it is decreasing its potential energy in steps. So decrease or increase in steps is called quantization. So you can say that this is quantized energy. That means energy is quantized, means it is in steps. It is not continuous. It is in the steps like a staircase. Right? Let's move on to the Bohr's model. Now, Bohr's model for hydrogen atom. One more thing I want to tell you here, Bohr model is for hydrogen and hydrogen-like species. Now what are hydrogen-like species? Those species which have one nucleus and one electron system. You know that in hydrogen there is a nucleus and one electron revolving around it. In helium plus there will be one nucleus and one electron. In lithium 2 plus again there will be one nucleus and one electron revolving around it. So the first postulate of this theory was the electron in the hydrogen atom revolves around the nucleus only in selected circular orbits. Again the quantization comes here. Certain circular orbits, and these orbits are associated with definite energies. If the energies are definite, so we have to go like in the definite manner. We can't go continuously. And these energy levels are called shells and numbers are like 1, 2, 3, 4 and we will call it first orbit, second orbit, third orbit, fourth orbit. It looks something like this. KLMN, K shell, L shell, M shell and N shell. More precisely if we say, we will say that first orbit, second orbit, third orbit, fourth orbit. If we talk about the quantization, energy of the first orbit will be constant and then energy of the second orbit again that will be constant. Electron will move around the nucleus either in the first shell or in the second shell or in the third shell, but not in between these shells. Right? That's why we call energy is quantized. Energy of the electron is quantized in first shell, second shell, third shell or fourth shell. It cannot be in between third and fourth shell. Now, how to find out the energy? There is a formula. Energy is equal to minus 2.178 into 10 to the minus 18 Z square by N square, where Z is the atomic number of that particular species and N is the shell number. Now this is joule per atom, means we are finding the energy for one atom. If we want to find out the energy for 1 mole, we have to multiply it by Avogadro number. And if we want to convert joule to kilojoule, we have to divide it by 1000 and that value comes out to be minus 1312 kilojoule per mole Z square upon N square. There is another unit of energy, that is electron volt. And what is the relation between electron volt and joule? In the last lecture we did it. 1 electron volt is equal to 1.6 into 10 to the minus 19 joules. So we will divide this expression by 1.6 into 10 to the minus 19 and we will get minus 13.6 Z square by N square electron volt per atom. So these are the formula of energy we will use while solving the numericals. Coming to the second point, only those orbits are permitted in which the angular momentum, now we are finding the angular momentum of the electron, it should be a whole number multiple of h upon 2 pi. It means that either the angular momentum, the value of the angular momentum will be h upon 2 pi or 2 into h upon 2 pi or 3 into h upon 2 pi or 4 into h upon 2 pi. It will be like that. Again it is quantized. 1 into h upon 2 pi, then 2 into h upon 2 pi. Angular momentum is also quantized, and if we say that we want the angular momentum like 1.33 into h upon 2 pi, the orbit will not be permitted. Why it will not be permitted? That we will discuss later on after de Broglie's hypothesis. For now, the orbit angular momentum of the electron will be equal to mvr is equal to nh upon 2 pi. M is the mass of the electron, v is the velocity of the electron, r is the radius of the electron of that particular orbit, and n is the orbit number. So where n is equal to 1, 2, 3, 4, 5, 6 and so on. Now coming to the third point, if energy is not given to any hydrogen atom or hydrogen like species, electron will revolve around the nucleus in the same path and keep on revolving, right? Energy will not increase, energy will not decrease. It shows that the energy of those orbits are constant, right? So look what he is saying, that as long as electron remains in the particular orbit, does not lose or gain energy, this means that energy of an electrons in a particular orbit is constant. That is why these orbits are called stationary states, right? But what will happen if they gain some energy or they lose some energy? Point number 4, when energy from external source is supplied to the electron, it may jump to the higher level, and when it will lose the energy, it will jump to the lower level, or you can say lower energy level. And when electron jumps from higher energy level to the lower energy level, we have already discussed in the hydrogen spectrum, it will give radiations in terms of electromagnetic waves, and we can find out the energy between those orbits. Delta E is equal to E2 minus E1, and that is equal to h nu, and we can write hc by lambda also. Now some more thing I want to tell you. The velocity of an electron in a particular orbit can be given by, the velocity of electron is 2.178 into 10 to the power 6 z by n meter per second, right? And the radius of the orbit, that is called Bohr's radius, that is equal to r is equal to 0.529 into 10 to the power minus 10 n square by z meters. Now for an orbit, if the total energy, now we know this formula, E is equal to minus 2.178 into 10 to the power minus 18 upon n square z square joule per atom, the potential energy will be double of that. So you can see that the potential energy will be equal to, we are not going into the derivation of this thing, but for the sake of the solving of the numericals in the competitive exams particularly, right? So if the energy is minus 2.178 10 to the power minus 18 up z square upon n square, the potential energy will be double of that, it is 2 into this value, and the kinetic energy of the electron will be positive of that value, that is 2.178 into 10 to the power minus 18 z square by n square joule per atom. Now, some important relation I want to discuss with you, and those relations again will be for hydrogen and hydrogen-like species. Let's talk about energy first. There are 4 shells K, L, M, N. If the energy in the K shell is minus E, then in L shell it will be minus E by 4. Next shell it will be minus E by 9, and the other shell, N shell, it will be minus E by 16, because energy depends on Z square upon N square, as Z is same but N is changing. So N square is changing, that's why energy will be having these values, right? So these will be the values of energy, and these are fixed values, and we can say that energy is quantized. Now radius, what was the formula of radius? It was 0.529 n square by z. Z is same, it is depending on n square. So if the radius of K shell is r, L will be 4r, M will be 9r, and N will be 16r. If we talk about the velocity, it will be v, then v by 2, v by 3, and v by 4 according to the formula. And we can find out the relation between the time also. Time depends on n cube. Since it depends on n cube, then if the time taken by the electron for one revolution in the first shell is t, then in the second shell it will be 8t, in the third shell it will be equal to 27t, and in the fourth shell it will be 64t. So these things you have to keep in mind. Let's solve some numericals.